The idea of a birth and a death of a universe troubles some people. The idea that we have sort of artificially subscribed, the idea that this had to start somewhere, and that it may very well be an infinite expansion and contraction, like waves going in and waves going out. The idea being that the entire universe may one day get to a point where it pulls down into itself and becomes one event horizon, one infinite piece of mass, and then starts all over again. Is that possible?
If you look at how the universe is expanding at the moment, then it is accelerating in its expansion. So the measurements tell us that the expansion rate itself is getting faster. And we have a name for that. We call it dark energy. So and of order 65-70% of the energy in the universe appears to be taken up in driving this increasingly fast expansion. So it looks like that looks like what's happening at the moment. So whether that can stop, whether there's something that can stop it in the same way as it seems to have stopped very early in the history, by the way, and whether that's true, nobody knows. We don't know the mechanism, but the measurements tell us of distant, particularly of looking at supernova in distant galaxies. The detailed modelling and measurements of that all suggest that the universe is accelerating in its expansion. So that would suggest that it's not going to rebound, because it's like a big rip scenario almost, where everything's accelerating. Space-time is stretching at a faster and faster rate at the moment. That seems to be what's happening.
So you feel that it's much more likely that there are infinite numbers of these things happening, that there's not just one Big Bang that creates this universe and we're watching this universe expand, but that there's infinite numbers of these things that are happening at the exact same time?
That's broadly speaking, I think many astrophysicists think that inflation's the best theory we have, because it makes predictions that agree with observation. So it's the best theory in terms of making the best predictions at the moment.
And this is that accelerating
that
in
a
its
very
expansion.
very fast superluminal, faster than light expansion that stops, and the end point of that is what we used to call the Big Bang. So that's broadly speaking textbook stuff. That's what you teach in undergraduate cosmology courses. Then some physicists argue that the natural extension to those theories are theories called eternal inflation, which are what you said, where so this exponential expansion of space-time is always going on, and it stops just in little patches, and that little patch is where you generate a new pocket universe, if you like, of which ours is one example. And you can have an infinite number of those, and they would be being produced now. And you can ask the question, how long has that been going on? And the answer is nobody knows. And there's a debate, even amongst the people who believe in those theories, about whether it could have gone on forever, or whether it would have started in what a colleague of mine at Durham, Carlos Frank, calls the mother of all Big Bangs. So was there a mother of all Big Bangs that set this process in motion? And in that thing that got that big fractal thing, you get loads of little Big Bangs. And the answer is this is cutting-edge stuff. It's very exciting. But so I'd say, just to be very precise, the inflationary bit, the simple bit, which was first put forward in the 80s, actually, by Alan Guth and people like that in the US, Andre Linde, another one, that looks right in the sense that it matches data very well. And the consequences of it are argued about and are active areas of research at the moment.
One of the things that people were terrified of about the Large Hadron Collider is that in trying to find the Higgs, that you might accidentally create black holes, little tiny ones that would just go eating through the Earth like a little ping pong ball that shot through the entire planet. That's idiots like me. Is it possible to create a Big Bang, or excuse me, a black hole? Is it possible theoretically to have enough power? Like if you don't have it right now with the Large Hadron Collider, is it possible that a larger machine will be created and human beings can recreate a black hole?
Yes, it's possible, yes. And it's possible if you have extra dimensions in the universe, right? So the thing is that, so we know gravity is a very weak force. It's by far the weakest of the four fundamental forces of nature. Billions and billions of times weaker than the other ones, which you can tell because you can pick up, a phone, even though the planet Earth is trying to stop me doing that, and I can just resist the pull of planet Earth. So gravity is very weak. So that gives you a clue that you can say, well, at what energy, how far do I have to go back in time, if you like, towards the Big Bang, before it's so hot that gravity is as strong as the other forces. The strength of the forces varies, I should say, with energy. So they change. And we've seen this behaviour. So two of the forces, so-called electromagnetism, which is the most familiar one, electricity, that one, and the weak nuclear force, which is one of the forces that operates in the atomic nucleus, they are the same force. They're manifestations of the same force, and we've seen this experimentally. And in fact, the Higgs boson is part of that process. And so we've seen the energies that they become the same force. So the idea is the other force, the strong nuclear force, if you go to higher energies and temperatures, converges, and then you'd have some things called grand unified theories. And then gravity makes its lethargic way back and unifies with them at something called the Planck energy, which is immensely short timescales after the origin of the universe, if you want to. Very, very hot. So way in excess of anything. So if you just want to just create black holes in a lab, then the naive thing is you'd have to go to those energies, and there's nowhere in the universe you'd never do it. You'd have a particle accelerator the side of the observable universe, and it wouldn't be big enough.
Wow.
But if you allow extra dimensions in space, so you imagine that, so we live in a three-dimensional space, and then there's time as well, so we've got 4 dimensions. If you allow there to be 5 or 6 or 13, I think the string theory, then what you can do is you can arrange for that energy scale at which gravity becomes important to come up, so the temperatures to drop. So you can arrange in some contrived way to get to the point where you could possibly access gravity, see gravity in action, as it were, in particle accelerators, at things as big as the LHC. And in that case, you would produce little black holes, which would then evaporate away very quickly, we think, through a process called Hawking radiation, and they'd be gone. So you can conceive of a way that you could, if given a big of a leap that there are extra dimensions in the universe, and given that they're configured in the right way, that you can imagine that you could do it. The interesting point, though, is that so LHC it's a tremendous technological achievement, but it collides particles together at energies that are just insignificant compared to the energies that are available in the universe to nature. So cosmic rays, for example, hit the Earth with energies far in excess of those that we generate at LHC. So whatever physics you can conceivably access at these particle accelerators is already being accessed now in the upper atmosphere of the planet, because the cosmic ray collisions are immensely higher energy. So if you can make little black holes because there are extra dimensions in the universe, then they are raining down on us now. They're here. They get made because the energies of the LHC, as I said, astrophysical processes all over the universe, way in excess, way exceed those energies. We're not very good at doing high energy collisions compared to nature, compared to supernova explosions, and compared to and cosmic rays. There's a cosmic ray actually that was detected. I think the highest energy one had the energy of a professional tennis player's serve. So 100-mile-an-hour tennis ball, right? And it's a single particle. So you imagine getting hit by a 100-mile-an-hour professional tennis player's serve on the back of the head. There are cosmic rays with that energy. But they're like, one particle.
One particle would be equal to getting served.
The energy of a 100 miles an hour tennis ball. So these are incredible energies.